Let's talk about how we get the answers. One way, you punch them into a calculator, you got an exact answer. Cool, that's awesome. But there'll be more to it. So let's see how we do it by hand. And we're just going to talk about some common angles again. Things like 0, 30, 45, 60, 90. Oh, I mean 0 pi over 6 pi over 4 pi over 3 pi over 2. Maybe we'll even go into negative values. Maybe we'll go with the other quadrants. We're going to use this. Let's just talk about how we do shit, kind of what's happening. No, let's mess with sine. If we were to just say that y is equal to sine of x, that's what we're used to. That was our first test. Notice I'm using an x and a y rather than a theta. You're going to see it with x's and y's a lot, so let's just get comfortable with it now. Our theta is our x value. Our angles are the x value when we write it like this. Okay? So let's see if we can't find these answers. Sine of, and let's put in 0. So sine of 0 is equal to, what's that equal to? Oops. 0. Cool. And alright, sine is equal to, and sine is equal to. We'll just do a few of these. I don't know. So what's sine of pi over 6? You get 1/2. Right? We know this. This is just all, this is a review. We're just making sure we got it. Sine of pi over 4, that's equal to root 2 over 2. Well, let's do one of these. What if I want to know what's sine inverse of 1/2? What's that going to equal? Dude, it's going to equal pi over 6 because you're just swapping your inputs with your outputs. So look at this one. What's sine inverse of root 2 over 2? It's equal to that angle, pi over 4, because you know what? Inverses are angles. Inverses, see, inverse, are equal sign, angles. Inverses are angles. I'll repeat that another 100 times throughout this section. Not this section, but the subsequent ones. It's a way to get out of trouble. Well, what we're also going to find is right up above. We have that sine inverse of 0 radians or 0 degrees, depending upon how you want to look at it. Oh shoot, I wrote that in backwards. See, inverses are confusing. Even your stupid ass teacher gets it wrong, huh? That's not abnormal. All right. So let's just continue it out. I just want to run it root 3 over 2, and that's going to be equal to sine of pi over 3, right? Got all these things, and then we can go with 1 is equal to sine of pi over 2. All right, we got this shit all on lock. Let's just punch it in. Now, what do we got here? You're like, well, what's sine inverse of the square root of 3 over 2? That's just equal to that angle, pi over 3. We'll go, what's sine inverse of 1? Well, shoot, that's just equal to the angle, pi over 2. I would prefer if you stayed in radians as much as possible throughout this. Degrees are cute. Let's stick to radians as we talk. I'm always going to speak pretty much exclusively about radians. So there was just kind of a quick go through, but we have the idea with sine inverse. We have that y is equal to sine inverse of x. Our domain, right, was from -1 to 1. So we could also be punching in negative values all the way up to, I don't know, -1/2, negative root 2 over 2, negative root 3 over 2, -1. We could punch those values inside. We could punch those ratios in. Now there's something dope about sine inverse. I'm going to change this to f of x. It's an odd function. Odd function. Which means f of negative x is equal to negative f of x. Or f of negative pi over 2 would be the same thing as just yanking that negative out to the front and just evaluating it at positive pi over 2. An odd function. An odd function. Actually, I drew it in wrong. My concavity is off. It would look like this. Kind of like a cubic, you know, like x to the third, an odd function. Saying if you punch in a x value here, you would get out some y value. And if you punched in negative x, you would just get the negative of that same frickin' y value. What this means for us is we can continue this on and say, well, wait. Sine inverse, let me make sure we don't confuse that. Sine inverse of negative 1/2. What our answer is, you know, negative pi over 6. It's just the opposite of that sign. It's like the negative just travels on out. It's like that negative just goes and pops to the outside or something. It doesn't, but it's almost like it does. But it's an odd function, so we're allowed to do that. You can't do that with even functions or functions that aren't odd. Write in the rest of them. So we're going to have, we'll put in our negative root 2 over 2. We'll put in our negative root 3 over 2. We'll put in our negative 1. And I'm pretty sure you can probably tell what's about to happen. You're going to get that negative pi over 4. Just getting into there. We get our negative pi over 3. And then we get our negative pi over 2. Now there's going to be all of our different values. Common angle values that could pop out. And notice the smallest number we can have is negative pi over 2. The largest number we can have is positive pi over 2. Okay, those are the only angles in between the first and the fourth quadrant. The only angles that we truly have here, when we look on the unit circle for sine inverse, oops. Okay, let's jump in. We only get, I like to make a little circle around it, so we only get values from negative pi over 2 all the way up to positive pi over 2. This is the fourth quadrant, this is the first quadrant. So if you want to refer back to your unit circle, there it is. There's your idea. But you can't put something in. If you have something like 11 pi over 6, that can't be the answer. It's bigger than pi over 2. We would have to find what it's coterminal to, like negative pi over 6 is the same thing. That's acceptable. Nothing larger than pi over 2 ever pops out of sine inverse. Now I'm going to run it through with tangent. Tangent is also, or we say that f of x is equal to tangent inverse of x. This is also an odd function. What we have here is, this is our angle. Inverse is our angles. That's our ratio that we'd be popping in. We have our common values that we can write. So let's do it. See if we can't follow along. So let's find out tangent inverse of, and let's put in its first ratio. Let's go with root 3. And then we'll go tangent inverse of, and let's go with 1. And then we'll go with tangent inverse of 1 over root 3. And we'll go with tangent inverse of 0. Not color coding, but it's the same game. It's just the values from here, saying we're now going to take our ratios and we need to line them up with the angles that match. We're swapping our inputs with our outputs. Oops, sorry about that. So this is going to become, the angle is pi over 3, because tangent of pi over 3 equals root 3. Tangent inverse of 1 equals pi over 4, because tangent of pi over 4 equals 1. And pi over 4 is in the first or fourth quadrant. Inverse tangent of 1 over root 3 is going to be pi over 6, because tangent of pi over 6 is equal to 1 over root 3, and pi over 6 is in between negative pi over 2 and pi over 2. Inverse tangent of 0 is 0. Because inverse tangent is an odd function, we could also say these. Inverse tangent of negative root 3 is equal to negative pi over 3. Inverse tangent of -1 is equal to negative pi over 4. Inverse tangent of -1 over root 3 is equal to negative pi over 6. And I can't use inverse tangent of -0, so that doesn't mean shit. Same time as 0. Not needed. So tangent inverse and cosine inverse, dude, they behave very nicely. Cosine inverse, it doesn't behave as nicely. It's not an odd function. It's actually an even function. It's an even function. It's going to not behave all that sweet. The next video is going to have to do with the one that doesn't play nicely. I'll see you in that one.